The purpose of this video is to provide a brief overview of the strategic profit optimization system, showing you the link to the belt scale data, the sales data, and how all that fits in with inventory cost and eventually margin. And at the end I'll show you some examples of the incremental value potential that comes from small variations in performance, yield, or sales targeting. The scale data, as you've seen from within the previous videos, is available automatically, accumulating from the daily format, which represents the hourly data. The summary data is actually extracted from the performance history and applied within the optimization, calculating yield and the production rates for the individual segments of the process. That data can be seen here in the production schedule screen, where the start month and end month, the minimum days and maximum days per week, etc. are accumulated. It can also be viewed and edited in the modes format, which gives you a picture of the yield, the percentage yield in the individual products and various configurations that the plant has set up. This example is using an actual full year of scaled data production from an operating plant site. You'll see here that I've set it up so it can go month by month, and as we do that and progress through the operating year, we develop a year-to-date trend information that is used to predict or project the balance of the year. You'll see on the right side of the screen, the yellow area, which is blank, is where the optimization would be applied. And as the month goes through in real life, you would be optimizing less and less. You'd have more historical data to project the end of year result on, and both sides of the calculation will become increasingly accurate. The same is applied to the sales. It's showing a sales forecast of 1.2 million and an actual achieved of only 1.1 million for this segment of the process. You'll see that the actuals from here are applied over here, and again the sales calculations and the optimization will be based only on the portion of the year that has not yet occurred. To begin the example, I will set things back out to a full year where there's no optimization been run, and I will run the optimization for maximum tons target.
Solver is using current constraints to calculate maximum potential cell tons. All constraints are satisfied.
You can see the calculation occurred on the optimization side, producing 1.9 million tons and sales of just under 1.1 million tons of sales. The sales comparison shows about a 2,000 ton difference between what was actually achieved and what was optimization achieved. Similarly on the 3/8 and then on the 1/4 inch. Now the interesting thing is it shows a margin over variable cost of 2,487,000 on the actual side, 2,064,000 on the optimization side. However, the revenue was higher on the actual side than on the optimization side, so there's a variance of 423,000 positive. The actual operating hours, scheduled hours, 2,831, 2,808. If you look at it in the context of the optimization of profitability, you would hit the
Solver is
maximum margin.
utilizing current constraints to calculate maximum potential margin. Solver calculations are complete.
You can see that maximum margin occurs with the plant only running 1,103 hours, but it shows a significant shortage of sellable product, which can't be practical. So what we would do is tell the system, using the constraints that we want to produce, at least 384,000 tons of 3/8 and at least 201,000 tons of 1/4 inch, and we run it again.
Solver is utilizing current constraints to calculate maximum potential margin. Solver could not find a feasible solution.
which tells us we don't have enough time allowed in the schedule. The capacity doesn't exist using this particular mode to be able to achieve the results that we have listed here in the constraints. So what we'll do is we'll go down and we'll open up a number of other modes that can be used for purpose of evaluating. Give the option to the optimization system to pick which ones in combination might be able to achieve the production that we just told it we wanted it to achieve. Do it again.
Solver is utilizing current constraints to calculate maximum potential margin. Solver calculations are complete. All constraints are satisfied.
So you can see with the other modes available, it didn't use the current year-to-date at all. It picked the maximum quarter-inch mode, maximum 3/8 mode for part of the year. The biggest part of the year went into this particular mode. These modes have been proven. They're field evaluation and scale observation. So these are all real modes with realistic yields. Whether they're achieved all the time or not is something that the scale system can tell you. But and actually the scale system can be set up to redefine those modes as they're used periodically over the course of a production year, so you can see the differences that occur as the crushers wear and the material changes. You can see that the result of being able to run with the yield as the target produces the equivalent number of tons of sales of sellable product, equivalent number, maybe a little bit higher revenue. But if you go up here, you see the scheduled hours of 2831, which was actual, and actual is recorded by the belt scale system. Compared to 1984 hours if you run it to focus on the production yield. The value of that is obviously quite significant because the variable cost of production at $4,500 per scheduled hour is $8.9 million on the optimization side, and the actual for the year in question was $12.7 million, calculated in the same way on the actual side, resulting in a $4.4 million advantage without any capital improvement. Now, you can look up here and you can say, well, it's not practical. We're not going to let the plant not operate in November and December because we don't have stockpile capabilities to deal with all of that. And we're going to get to that part in just a minute. But what you would do then is you go up here and you adjust the operating schedule to make sure things are spread out through the course of the year. So you're going to say you're going to run a minimum of 4 days per week. Minimum of 3 days per week here, because it'll drive it up further as we need it. And we run it again, and without changing rates or runtime, just continue to.
Solver is utilizing current constraints to calculate maximum potential margin.
Continue to evaluate the scheduling and yield selection. So you can see that the year was filled out. The hours are essentially the same though, 1900 versus 2800, just fewer hours per month. You can see that the production up on the top was significantly less, about 300,000 tons difference, much of it in products that were not sellable. So we've got a significant advantage in operating if we can pick the modes that we know represent yield of sellable product. You can see the effect graphically here. 2.487 to 6.976, pretty significant difference, and you can see the difference in the the variable cost of 12.7 versus 8.9 million. All very real. The ton per scheduled hour, 660, same thing, 880 on the ton per operator hour, so no change there, no change in the runtime. The only change was in the fact that we selected modes to operate that presented or better represented the demand for sellable product. This can be looked at on the inventory side, and you can quickly see that there's an issue at the end of the year, so a constraint needs to be placed in to not run out of certain products. So this inch and a quarter started out at 13,000, so we'll tell it we need 13,000. We'll try to keep the inventory change out of the equation. 30,000 end of year, 60,000 on the 3/8. Let's say 10,000 here on the 1/4 inch, and we'll not mess with that. It's a byproduct, and we'll not mess with that as a byproduct. So what we'll do again, put those constraints in and run it one more time.
Solver is utilizing current constraints to calculate maximum potential margin. Solver calculations are complete. All constraints are satisfied.
So you can see we went from 1900 hours to just about 2200 hours, but we're still looking at a $3.5 million positive variance, and we do have the ending inventories that we decided that were necessary. At the same time, we can look at production, and we can see the comparison on the reported or the measured actuals versus the projection. So we're not developing excessive inventories of anything. We intentionally added a little bit to the 3/8 when we put the constraint in. We can put constraints on production here also, as we choose. We also have a capability to adjust the scaled data. This is all based on scale data, by putting in an adjustment factor to represent a potential loss on a stockpile or loss on a wash. So, for example, if I go to the 5/8 product and I tell the system that yeah, we know we produced 169,000, but we think we're going to lose 5% in handling. It takes 9,000 tons off, and giving you the ability to create a dual report, one showing the scaled production and one showing what you expect to be available on an inventory reconciliation. So your inventories now become more representative of the realities that exist within a quarry operation. There will always be losses. If you put 10,000 tons into a production, through a primary crusher and send it into a plant, and expect to get 10,000 out, you will always be wrong. Sometimes it could be as high as 9,000 or 9,500, but that's rare. More likely to be something under 9,000 overall in terms of the measured results on the inventory side. Okay, so now let's take a quick look at what incremental effect of small changes can have on the process. Let's take our runtime percentage from 75% to 85%, and you'll see that affects the ton per scheduled hour, and it doesn't affect the ton per operated hour, but the ton per scheduled hour goes up. So let's see what happens there. The 3.55 and the 2.191 are what we're looking to compare to.
Solver is utilizing current constraints to calculate maximum potential margin. Solver calculations are complete. All constraints are satisfied.
So you can see the hours dropped, the profit went up, simply by increasing the operating time, the percentage of operating time where material was actually flowing on the belt. Now we could do the same sort of thing with the ton per operated hour. This particular plant is limited in terms of its top end by the feeder at the surge pile, but it can easily run 960 tons per hour on average, and has done that for the entire day. So now we change that parameter by a small amount and run it again and compare 4.3 million and 2029.
Solver calculations are complete.
Small changes with big results. Now we're 1,000 scheduled hours off, producing the same amount of product in less time, with a similar shift in operating mode selection, but obviously less hours. The automatic linking of the belt scale data makes the modes valid as can be. You can see the rate and runtime and yield links are intended to represent the best possible source of value. You can see the linking of the sales data is almost invisible. The constraints and targets are used to make the optimization model realistic. Finding the added value potential becomes fairly easy. And you can see the significant potential exists with small changes to increase value significantly.